Okay, good day. And so we're going to talk about your activity number 4, that is your routine urine analysis. And so this time we're going to see your chemical exam of your chemical exam included in your routine urine analysis. And so with this, of course, you have here your determination of your protein, your specific gravity, your ketones, your glucose, your urobilinogen, your bilirubin, your pH, and the rest of the test with this. And so, of course, that are not included in your physical exam and microscopic exam. Okay, and so with this, and so let's take a look. Under your physical exam, and so I mean under your chemical exam, and so you have here your heat and acetic acid test. And so your heat and acetic acid test here is a test for proteins, for albumin. Okay, and so this is a test for your proteins. Okay. With this one, of course, and so in your heat and acetic acid test, and so the protein present in your urine is coagulated by heat and precipitated by acetic acid accordingly. And so the acetic acid that is used here is you have a 5 to 10% concentration of acetic acid, of course. And so with this, the degree of turbidity will produce, I mean the degree of turbidity produced, and so in your heat and acetic acid test, and so is proportional to the amount of protein present. Of course, and so the pure proteins, and so as what we talk in your biochemistry, and so they are complex three-dimensional structures, and so that are what we call this stabilized by various chemical bonds and interactions, no? And so, of course, when you apply heat to a protein, and so it will destroy the three-dimensional structure or the structural arrangement of your protein. And so, with this, it will cause a destruction, and so destruction of its native conformation. And will lead you to denaturation of the protein. Of course, with this, and so after the protein is denatured, then your protein molecules will undergo coagulation or precipitation. With that, the addition of your acetic acid during this testing, and so will help in the coagulation process. Okay, and so let's take a look at the a step-by-step procedure in doing this. So, of course, and so your acetic acid again, and so will destabilize your protein structure. And so with that, you already denatured, and so there is no, the structure is not already stable, and so it is somewhat destroyed. And so with that, it will further destabilize your protein structure, and that will promote the aggregation of your denatured protein, no? And so that will lead to the precipitation of such. Okay, and so to produce a turbid solution. Okay, and so for the positive results of this, of course, if there is no turbidity, and so uh, change in the structure of, I mean, change in the clarity of your solution, then that will be reported as a negative, of course. And so for the positive results, and so if you have a 1 plus, and so positive 1 plus, and so you have it as a diffuse cloud. 2 plus, and so you have it as a granular cloud. 3 plus, and so that is a distinct flocule. And then 4 plus, that is a large flocule, and so you have a dense or something that is solid, and so in the yes, in the solution. Okay, and so let's take a look at your step by step procedure of doing your heat and acetic acid. And so with this, of course, you need a test tube, and so fill it at least two-thirds full, and so with a freshly voided urine sample. And so when the sample is cloudy, and so if your sample is turbid or cloudy, and so you do centrifuge. Okay, and so you centrifuge the preparation for 5 minutes at 1800 rpm. But then if your sample is clear, if the fresh urine voided is clear, then you don't need to do centrifuging. Okay, centrifugation. Okay, the tube should be held at an angle over the flame, and aimed away from the body. And so, heat and acetic acid test is being also done in biochemistry, no? And so, clamp the mid portion of the tube, then evenly heat the upper one third of your preparation by turning, of course, the bottom of the tube with one hand while the other holds the test tube holder accordingly. And then, of course, you allow the preparation to boil. Of course, when doing this, and so make sure na hindi nakatapat sa'yo yung the open portion of the test tube, no? And also make sure na walang ibang tao doon. Okay? And then observe for the presence of cloudiness at the heated portion against a black background. Of course, with that, at such temperature, and so proteins will precipitate. Proteins will coagulate, and so giving you cloudiness. Okay, and so this time, and so when there is a cloudiness, when you have cloudiness that will appear, and so uh you add, okay, and so you add 3 to 5 drops of 10% acetic acid. And so in this one, and so you reheat the preparation as in your procedure 3 and observe for cloudiness. Okay, and so if your cloudiness, and so if the cloudiness that is initially formed will disappear, and so that after the addition of your acetic acid, and reheating, and so the substance present is phosphate. But then if the cloudiness will persist, and so probably that is albumin or amorphous urates. Okay, and so again, if it persists, and so you have your choices, probably you have it as albumin or amorphous urate. Okay, and so with that, with this, of course, if there is no, what they call this, if there is no cloudiness, and so that has taken place, and so in your procedure 6, then of course, no need to do your the addition of acetic acid. No? Okay, and so with that, that is for your heat and acetic acid test. Moving on. And so again, your results in interpretation. And so this one is lifted from your module. And so negative, of course, absence of cloudiness or no change still in your clear urine. Okay. Trace, cloudiness is barely visible. Cloudiness, positive 1. And so cloudiness is distinct but not granular. Positive 2. And so cloudiness is distinct and granular. And then positive 3, cloudiness is heavy with distinct flocules. And then cloudiness is dense with large flocular for positive 4. Okay, and so with that, and so that is again a test for your that is again a test for your albumin and your heat in acetic acid test. This one is accordingly the reference method. Okay, and so the reference method. And then you have your SSA. You have your sulfosalicylic acid. Okay, and so your sulfosalicylic acid. Okay, and so your SSA, and so is will what they call this the acidic environment of your SSA probably. And so because with this you're going to add 3% of SSA and 3 ml of 3% SSA and 3 ml equal amounts, no? And so to acidify. And so with this acidic environment, and so will denature your proteins in the urine. And so with this, of course, and so same, it will cause the proteins to lose the original conformation. And so that will lead, of course, to denaturation of your proteins and then precipitation. And so primarily, and so of your albumin. Okay, and so with that, your denatured proteins will form a turbid or cloudy precipitate in the urine, and so that will indicate the presence of your proteins. And so with this, your SSA again, and so your sulfosalicylic acid is an what you call this is an acidic reagent. Okay, and so with that, of course, and so most proteins are precipitated by dilute sulfosalicylic acid. And so the reagent is 3% sulfosalicylic acid. Okay, and so you have here the grading of such. Okay, and so you have here the grading. Again, and so you have a 3 ml of 3% the acetic acid, sulfosalicylic acid plus 3 ml of urine. Again, and so if your sample is clear, then don't you accordingly no need to centrifuge. But then if your sample is cloudy, and so you do centrifuge. Okay. Okay, and so you have here for the reporting, and so of course negative, there is no increase in the turbidity. Trace, there is a noticeable turbidity, distinct turbidity, and so for positive 1 plus 1, and you have here the range of your quantitative amount of protein present, no? And then you have your turbidity granulation and no flocculation. And so that is at 100 to 200. And so for 2 plus, 3 plus turbidity granulation and flocculation is observed. And so 3 plus, and so giving you 200 to 400. And then your clumps of protein, that is 4 plus, the protein content is greater than 400. And so again, when your SSA, and so it utilizes your 3% sulfosalicylic acid. Okay, and so let's take a look at this procedure. And so your test for your albumin still, and so your sulfosalicylic acid. Okay, and so you add 3 ml of 3% sulfosalicylic acid to 3 ml of centrifuged urine. Okay, and so you mix by inversion or gently mix. Okay, and so gently mix and observe for cloudiness. And then of course after that, and so you grade your degree of turbidity. Again, and so the turbidity will correspond to the degree of turbidity will correspond to the amount of protein present. Okay. And then you have your Benedict's test. And so your Benedict's test here is a test for your glucose. And so your Benedict's test, this one is a test for your glucose. No? And so in your biochemistry, and so you do this almost every experiment, your Benedict's test, no? And so with this, it is a general test for glucose and other reducing substances. And so reducing substances, these are substances that can reduce copper sulfate to cuprous oxide in the presence of alkali and heat. Okay, and so with that, of course, to produce you a what you call this a colored product, and so for your Benedict's test, of course. And so with that again, and so that is for your reducing sugars. And note that your glucose, that is a reducing sugar. And so for this, your sugar plus your what you call this your copper sulfate plus your reducing substance, and so will produce you your cuprous oxide, no? And then of course this one will give you a color. Okay? Okay, and so for your Benedict's test. Okay, and so let's take a look. Your results and your interpretations. And so you have here no change. And so if negative, of course, you have trace. And so bluish green color without any precipitate. Okay, and so positive one, greenish yellow solution with yellow precipitate. And then positive 2, yellowish green with yellow precipitate. And then positive 3, yellowish orange with yellow precipitate. And then orange red with brick red precipitate. Okay, and so for your positive, for negative one, of course, the color of your reagent, the color of your Benedict's reagent is retained, and so as blue. Okay, and so it is retained as blue. Okay, and so for your procedure, you test for your glucose, you have your Benedict's test, and so you add 5 ml, place 5 ml of Benedict's reagent in a test tube, and then add 5 drops of urine sample, and so 5 drops or 0.25 ml of urine sample. Okay, and then you mix and then you heat. Ayan, so you heat in a boiling water bath or in over an alcohol lamp, no? And so over an alcohol lamp for 2 minutes. And so for 2 minutes. And so still, and so you always make sure na hindi nakatapat sa'yo the opening of your test tube or nakatapat sa ibang tao. Kasi if you are heating urine, and so there is a great possibility na that it will, what you call this, overflow, no? Ayan, so, and if you're using your water bath, ayan, so 5 minutes, you do 5 minutes when you heat it for 5 minutes, and so when you will use a water bath, no? And then, of course, remove the preparation. And then, of course, you allow to cool. I mean, you read. I mean, you remove the preparation and then you read your results immediately right after heating. Okay, and so you already have the grading as such. Of course, if blue lang siya, then that is negative. Okay, and so your urine does not contain glucose accordingly. And then, of course, you have your microalbuminuria. Your microalbuminuria here, and so this is a condition again, and so your microalbuminuria is a condition that is characterized by the presence of a slight increased amount of albumin. And so there is a slight increase of the amount of albumin in the urine accordingly, and so that is for your microalbuminuria. And so in this case, your microalbuminuria, ayan, so is what they call this a proteinuria that is not detected by routine reagent strip testing, and so this is not detected by routine reagent strip. And so what is the significance of this is accordingly, and so it indicates, and so with this for your the presence of, I mean, the presence of microalbumin in the urine, and so indicates glomerular dysfunction, probably nephropathy. Okay, and so it indicates glomerular dysfunction, and so probably nephropathy. And so again, it signifies, and so it indicates an onset, and so it indicates an onset of renal complications of your diabetes mellitus. And so indicates onset of renal complications of diabetes mellitus, and so these complications are known as is known as diabetic nephropathy. Okay, and so we have as such, and also, and so your microalbuminuria is associated with an increased risk of cardiovascular disease. And so again, it is not only a marker of kidney damage, but associated with increased risk of cardiovascular disease. And so note that those with though note that those individuals with microalbuminuria, and so especially those with diabetes or hypertension, may have a higher risk of developing heart disease accordingly. Again, and so they have a higher risk of developing a heart disease. Okay, and so you have as such. Okay, and so for your microalbuminuria. And so, of course, you have your test. And so, for this one, you have your methods in detecting your, since it is not detected by routine reagent strip testing. And so, you have here methods. You have your quantitative procedures for albumin using 24-hour urine sample. And then you have your micral test. Ayan, so micral test and immunity. Of course, we're going to talk about the one in the lecture in detail, and so during your lecture. And aside from those, your indication of onset of diabetic nephropathy, and so associated with increased risk of cardiovascular disease. And so this one is also, your microalbuminuria is also used to assess the course of kidney disease. And so, of course, to monitor, no? And so the progression of kidney disease. Okay, and so monitor the progression of kidney disease. Okay, and so you have as such. Okay.